Welcome to the deep dive. Today we're getting into something really fundamental for anyone in crypto, managing keys. It can feel like you're juggling security and usability, right? Yeah.
Absolutely. Yeah, for the early folks, key management was a huge pain point. Imagine needing a totally unique random password for every single online purchase,
Oh,
ever.
wow. A new one each
A
time.
new one each time. That's kind of the complexity they were dealing with.
Right. And if you lost just one of those digital keys, whatever crypto it unlocked was just poof, gone.
Exactly. It was like having this massive keychain, hundreds of individual keys, lose one, and that locker stays locked forever.
That's a great analogy. Thankfully, things got smarter. We got deterministic wallets.
That was the big leap. Deterministic wallets brought in this brilliant idea. Generate all your keys from one single starting point. A secret called a seed.
Okay, so like that master key idea. Instead of the giant ring of keys, you have one key that can somehow make copies of all the others.
Precisely. So backing up suddenly becomes way simpler. Just protect that one seed, and you've essentially backed up everything.
That's a huge relief, I bet. And today, we're going even a bit deeper, looking at hierarchical deterministic wallets, or HD wallets.
Yep. HD wallets take that one seed, many keys concept, and add structure, like a tree.
A tree structure, so organizing the keys.
Exactly. It's like having that master key, but it doesn't just create other keys. It organizes them into like different branches or folders, all still coming from that original seed.
Interesting.
And, what's really striking is how this structured approach, all based on that one secret, is now basically the standard everywhere for almost every crypto wallet.
So our mission for this deep dive is really to understand the core ideas behind HD wallets, why they're so important, but, without getting lost in all the super technical weeds.
Exactly. Let's get the concepts down.
Okay, let's rewind a bit then. What exactly was the big problem with the old way, the non-deterministic wallets?
Well, the main challenge was just the complete lack of connection between the keys. Every time your wallet needed a new address to receive crypto,
Uh-huh.
it would just generate a totally new, totally unrelated private key. Key A had nothing to do with key B.
So it's like if I wanted someone to mail me a letter, I'd have to give them a completely random, brand new address every single time, one that's unconnected to any I used before.
That's it, exactly. And that created this massive headache for the user. You had to personally back up every single one of those independent private keys.
Every single one.
Every single one. Think about using crypto for years, making lots of transactions. You'd end up with this huge, sprawling list of vital, unrelated keys, all needing secure storage.
Wow. That sounds incredibly risky. Like forgetting just one could be catastrophic.
It was. If you missed backing up just one key, or, maybe a backup file got corrupted,
Yeah.
any crypto tied to that specific key was basically lost, gone. Like having house keys scattered everywhere, lose the key to the back room, and you might never get in there again. No way to make a copy.
Okay, that paints a very clear picture of the problem. So how did deterministic wallets change the game? Tell us more about this seed.
Right, the seed is the core innovation. It's this single piece of data. Often, it's shown as what's called a mnemonic phrase.
Ah, the list of words, like 12 or 24 words.
Exactly, usually 12 or 24 common words. And the key insight is that all the private keys and the public keys that go with them are mathematically derived from that one seed, using a predictable algorithm.
So it's like planting one seed and this whole garden of crypto keys just grows from it predictably.
Perfect analogy.
Yeah,
And the massive advantage is you only need to back up that one seed phrase.
just the words.
Just the words. If your phone breaks, computer dies, hardware wallet fails,
Yeah.
you just take that seed phrase, put it into a new compatible wallet.
And it regenerates everything, all the old addresses and keys.
Regenerates everything. It's like that master key analogy. Again, it can recreate all your individual house keys if the main set gets lost.
That is incredibly reassuring. Takes away a lot of that anxiety about managing this growing pile of secrets. Just one phrase to guard.
Right.
You mentioned a mnemonic phrase. Is there like a standard for how those words are generated or chosen?
Yes, definitely. The main standard is called BIP-39. It lays out how to turn basically random data into that sequence of human-readable words.
Which is huge for usability, I imagine. Trying to copy down a long string of random letters and numbers perfectly.
Oh yeah, that's just asking for errors. Words are much easier to write down, to double-check, even maybe to memorize, though writing down is safer.
And I've heard that sometimes just the first four letters of each word are enough to identify it from the standard list.
That's often true, yeah. The BIP-39 word lists are designed very carefully so words aren't too similar, minimizes confusion. Adds another layer of practical safety.
Okay, so deterministic wallets, big step up. Then HD wallets add this. Tree structure. How does that provide even more benefit?
Right, so hierarchical deterministic wallets, these came about with BIP-32. They build on the seed concept but organize the key derivation into that hierarchy, that tree.
Okay,
At the very top of the root, you have a master key. Think of it as like an extended version of the key derived directly from the seed.
got it.
And from that master key, you can derive child keys. And those child keys can then derive grandchild keys and so on, creating branches.
Like a family tree. Master key is the great-grandparent, then child keys are grandparents, branching down.
That's a really good way to think about it.
Ugh,
Or like organizing company finances. You have the main company account, right?
right.
Then you might create sub-accounts for departments like marketing, sales, R&D. In an HD wallet, the master key can generate the main keys. Then you can derive distinct sets of child keys for, say, different cryptocurrencies or different purposes.
Ah, okay. So I could have one branch of my key tree for my Bitcoin spending, another separate branch for my long-term Ethereum savings, maybe, all from the same seed phrase initially.
Exactly that. It allows for much better organization. And BIP-32 also introduced something called the master public key.
Master public key, what does that do?
So this is derived from the master private key. But the crucial difference is it can generate all the public addresses down the entire hierarchy.
Okay, so all the addresses you use to receive funds.
Right. But it cannot generate the corresponding private keys. So it can't spend the money.
Wait, really? So you could give someone this master public key, they could see all your addresses, check all your balances across the whole wallet structure?
But they couldn't move a single cent.
Precisely. They can't sign transactions without the private keys.
That sounds incredibly useful for certain things, like transparency. Definitely. A major use case is for businesses or maybe organizations. They could give their master public key to auditors.
Ah,
The auditors can then see and verify all the transactions, all the balances across all accounts, without ever getting access to the actual spending keys. Total visibility, zero risk of theft from the auditor.
that's very clever. Like letting them see all the mailboxes and the mail delivered, but they don't get the keys to open the boxes.
Great analogy again.
Okay. And then there's BIP-44. I remember hearing that one too. How does that fit in?
BIP-44 builds on BIP-32.
Mhm.
It basically defines a standard path or structure within that hierarchy. It's specified like which level of the tree is for the coin type, Bitcoin, Litecoin, whatever.
Okay.
Then another level for different user accounts within that coin. Then levels for whether it's an external receiving address or an internal change address.
So it's like a standardized filing system for the tree. Universal folder names, basically.
Exactly. It means different HD wallet software can understand each other's structures. So you could, in theory, back up your seed from one wallet and restore it in a completely different wallet app, and it would find all your coins and accounts correctly. Makes things interoperable.
That makes a lot of sense. Standardization is key there.
Okay, so we've kind of got a handle on how HD wallets generate and organize keys. Let's talk about how this actually boosts privacy and security over the old random keys.
Right, because just having one backup is a huge security win already. But what else? Privacy.
Yeah, a key privacy benefit is that HD wallets make it really easy to generate a fresh public address for every single transaction you receive. Automatically, usually.
Why is that important?
Well, the blockchain is public, right? If you keep reusing the same address over and over, anyone watching can easily link all those transactions together. They can start building a profile of your financial activity.
Ah, I see. It's like always using the same P.O. box. Someone could just watch that box and see all your incoming mail.
Precisely. By generating a new address each time, an address that looks totally random on the surface, but is actually linked back to your seed HD wallets, make it much harder for observers to connect the dots and track your funds across the blockchain.
So better privacy through kind of cryptographic camouflage.
You can put it that way, yeah. And security-wise, the main point remains. You only need to secure that one thing, the master private key, or more practically, the seed phrase that generates it.
That single point of failure, but also that single point of control.
Exactly. Keep that seed phrase secret and safe, and your entire hierarchy of keys and all the funds they control are secure. That's the foundation.
And the recovery phrase, those 12 or 24 words from BIP-39, that's the user-friendly way to back up that master control.
Yep. Which leads back to the absolute golden rule of crypto security.
Keep your seed phrase offline, safe, and absolutely secret. Don't screenshot it. Don't email it to yourself.
Please don't. Write it down, store it securely, maybe multiple copies in different safe places. Anyone who gets that phrase gets your crypto. Full stop.
Right. Okay, now I know many people listening are interested in Cardano. Can we quickly touch on how Cardano uses these ideas?
Sure. Cardano wallets definitely use deterministic key generation. When you set up a dataless or Yoroi or whatever wallet,
Uh-huh.
you get a seed phrase. And from that seed, the wallet generates your addresses. So you get that core benefit, simple backup, and the ability to generate multiple receiving addresses.
So when my Cardano wallet gives me a new address when I click receive, that's this HD wallet principle at work.
That's it. However, there's a bit of a nuance with Cardano. It uses something called a stake key.
Ah, yes, for staking ADA.
Right. And typically, all the different receiving addresses generated within your wallet are linked to or associated with that same stake key for delegation purposes.
Okay, so even if I have lots of different receiving addresses, like different mail slots,
They're all tied back to the same staking identity.
pretty much. It means on the blockchain, while you have different addresses, it's often quite easy for an observer to see that addresses A, B, and C are all delegating to the same stake pool via the same stake key.
Ah, so it makes it easier to link those addresses together, potentially identifying them as belonging to the same user.
Exactly. So you get the backup convenience of deterministic wallets, but the privacy benefit of using multiple addresses is somewhat reduced because of how the staking mechanism links them. It's a design choice, a trade-off. That's a really interesting real-world example of how these things get implemented. Okay, so wrapping up, what are the main takeaways about HD wallets?
I'd say there are three key advantages. First, massively simplified backup and recovery, just the seed phrase. Second, enhanced privacy, because they make it easy to avoid reusing addresses. And third, better organization, plus that master public key feature for things like audits.
And the absolute bedrock of it all is protecting that seed phrase.
Couldn't emphasize that enough. That phrase is control over your funds.
So here's a final thought to leave you with. As our digital world evolves, with digital assets, digital identity, how else might these core ideas of deterministic key generation be used? Could we see similar hierarchical systems managing other kinds of digital secrets, trying to find that sweet spot between security, privacy, and actually being able to use things easily? Something beyond just crypto.
It's a fascinating question. The principles are quite powerful.
Definitely something to ponder. Thanks for exploring the depths with us today.